You can't tell if an AFR sensor is working properly just by looking at the fault code. Now we will examine the professional testing method step by step using an oscilloscope. Before starting the measurement, the connections of the heater, reference, pump cell, and Nernst cell must be correctly determined according to the manufacturer's pin diagram. The first step is to correctly locate the sensor. The broadband AFR sensor is located before the catalytic converter and typically has a 5 or 6 wire connector. Now let's measure the resistance between the heater pins of the sensor. This value can range from 1 to 15 ohms depending on the sensor type. Very important warning: absolutely do not check the resistance between the pump and Nernst cells of the AFR sensor with an ohm meter. The sensor may be damaged. We are currently connected to the vehicle with the Bosch KTS EasyTronic. After the engine is started, the sensor first reaches an operating temperature of approximately 700 degrees on its own. When the engine reaches its normal operating temperature, the lambda value on the Bosch FSA 760 should approach 1, and the system should operate stably. When you lightly press the gas pedal, the pump flow changes. The ECU uses this change to calculate the actual air-fuel ratio. When you apply throttle quickly, the sensor's response should change without delay. Slow responding sensors can lead to performance loss. A sensor in good condition responds quickly and reliably. However, a faulty sensor will give a delayed signal, become unstable, or get stuck at limit values. For accurate fault diagnosis, not only the sensor signal but also the lambda value, fuel trims, and engine operating conditions must be evaluated together. Diagnosis is made by correctly connecting the sensors, performing oscilloscope analysis, and evaluating. These 3 steps ensure the reliable diagnosis of sensor malfunctions.